All right. What's up, everybody? Welcome, welcome. It's been a couple of weeks, I know. Missed you guys. I love to stream every single week. I was going to do some kind of like a late show or even a Tuesday episode, but you know, sometimes you get other obligations, especially around this time of the year, heading into the holiday season here in the States, at least. I think that's pretty much universal around the world. So had to make sure that we took care of our local obligations, and unfortunately weren't able to stream last week, weren't able to stream the week before, but we're back. We're back this week, December 11th. We're going to be back next week, December 18th. I don't think we're going to live stream on Christmas Day. I don't know. Maybe if I get up before all of my roommates, maybe I can sneak down here and do a super early morning live stream, but I don't think we're going to stream on Christmas Day. Amir Shea is in the chat. What is up, Amir? Amir has been crushing it on the practice models playlist, doing all the practice models, giving lots of great feedback, ideas, different ideas on how to do some of these models. Love seeing your comments in there. Welcome, welcome, Amir. Aaron C is here, our tournament Final Four finisher. What is up, Aaron? We got a special model for you today in our challenges today. And John Degestein is here. Jern, what's up, what's up? Build 123D CAD Pro, welcome. Chris Knudsen, old friend of the show, welcome, welcome. We got Krasimir here, new here for the first time, welcome. Thanks for joining us. Great to see you here on the live stream. Let's get into it. I know what you guys are here for. You're here to find out who is the fastest in the chat. So welcome, welcome. Thanks a lot for joining us. Today is December 11th, and we're going to get into some CAD modeling practice and some CAD modeling 2D to 3D challenges for everyone, no matter what CAD system you're using. All CAD are welcome here. So today we're going to do two CAD speed modeling challenges. We're not really going to talk about the tournament much. We're going to talk about some live solves using Onshape. We're going to interact with the best chat ever. And while we are going through and modeling our parts, I'm going to go through and model a couple parts. I'm going to do this one first in Onshape. A nice simple part using inches, modeling in ABS. I'm going to model this one in Onshape in the second half of the show. A little bit more of a challenging part. I know that this one definitely caused some struggles, and a lot of people were wondering, like, can Onshape even do sheet metal like this? And the answer is yeah, of course, absolutely. And we're going to show you how to do it in Onshape and how to come up with the correct mass. So let's get into it though with your challenges. And of course, if you enjoy this kind of content, be sure to support the channel. There's a lot of ways you can support the channel, but the easiest way to do it is just to hit the like button. Looks like we got 6 likes right now. It looks like we got about 18 people watching. So let's see what we can do. Let me go over to my monitoring computer here and make sure that I hit like on the monitoring computer. Let's make sure that everybody goes and hits that like button, hit the subscribe button. If you're watching from your phone and from your computer, like it from both devices. If you're watching the recording, be sure to like the video. Be sure to go down into the comments and leave a comment. Always very helpful. There's also some other ways you can support the channel. You can share and you can reshare. Great way to support the channel. And of course, you can contribute at TooTallToby.com/donate using the value for value system. If you get value out of these types of challenges every week, send some value back. This guy here, you can see he's a huge fan. He's got the poster up on the wall. He's got the TooTallToby sticker on his laptop. He's got his credit card out. He's ready to donate at to the value for value, TooTallToby.com/donate. Or, of course, you could use the super chat here in YouTube. All right, guys, let's get into it. Today's CAD speed modeling challenges are going to feature a 2D print, which you out there live in the chat are going to turn into a 3D model. And you're going to then try to calculate the mass and enter that mass directly into the YouTube chat. Now, the basic rules of this challenge are that you can use any CAD package. As long as you can input the density and output the mass, you are in the right spot. Make sure when you answer these questions that you answer with the correct specified precision. So like this model here, you can see it's in pounds. I'm looking for the answer in x.xx pounds. So don't just put in like 5 pounds. You're not going to be within tolerance if you do that. If you put like 5.25827, that's fine. You can be more precise, but don't be less precise or else you're not going to be within the specification. And make sure that you are the first person to answer correctly in the chat. If you're the first person to answer correctly in the chat, you will be declared the winner. You will earn the point for the day. The units that we use here in Model Monday Live are the units that are showing on screen right now. If you're here for the first time, you might want to take a screen capture. That way you will always know what units we use here in Model Monday Live. We use IPS and MMGS. We use plain carbon steel, 1060, aluminum alloy, and ABS. But who knows? This is 2023, and we are coming to the end of 2023. Maybe next year we'll mix it up a little bit. Maybe we'll add a material to this list. Maybe we'll change out one of these materials. I don't know. We'll mix it up, I'm sure, in 2024. Which will be, I believe, Season 6 of Model Monday Live, if I'm indexing correctly. Maybe Season 5, I can't remember, but I think it's Season 6. The advanced rules for this Model Monday Live episode are it's meant to be fun and good-spirited. I will make mistakes occasionally. Again, a little shout-out to Aaron C. in the chat. I think he's going to like this model today. And the Ivan exploit is permitted in this challenge. If you want to utilize the Ivan exploit, you go for it. Sometimes I think people spend more time trying to find those exploits than they would take if they just modeled it straight. But you go for it if you want to use that Ivan exploit. He's always in the top 4. So, there's got to be some merit to that exploit. All right, guys, here we go. Let's flip over to full screen. I'm going to show you the full screen print. As soon as I show this, the challenge is live. Here we go. Challenge number 1 for December 11th goes live in 3, 2, 1, go. What is the mass of this part in XXX grams? The material is 1060 alloy. A little change here. This is a very similar part to a part that we used in the tournament, but I think the tolerance was maybe just a little too tight in the tournament, so we loosened it up a little bit here. The material is 1060 alloy. The tolerance is plus or minus 5 grams, so you're going to answer in XXX grams, and when you go to answer this, you can be within plus or minus 5 grams. Got really a 10-gram swing there. Pretty big swing there for just three-place precision. But as Aaron is hinting to in the chat, we noticed that there was quite the deviation on this thing if you used a guide curve versus not using a guide curve. Aaron, actually, in auditing this, I know you're trying to model this, so you probably don't want to hear my backstory about this model. But in auditing this, what I found was that if I used one guide curve, recognizing that the ellipse has symmetry, just using one guide curve to maintain or really limit the amount of twists that occurred in the loft, one guide curve was the magic number. And that seems crazy to me that somehow got through our auditing process. But like I told you in email, for the finals, we had 3 different people auditing these models to make sure that modeling them in a variety of ways would yield answers that are within the spec. And somehow this one got through. So there are always going to be anomalies. That's why we have the it's meant to be fun and good-spirited rule. And I will make mistakes. And I really had a good run in the tournament. Didn't make too many mistakes. But of course, we got to the finals and we had this beautiful print, and it has its own little backstory now, and I'm sure it'll make its way into an NFT at some point. All right, guys, enough talking from me. I hope that you enjoyed that backstory. This is your challenge. Try to take that, turn it into a 3D model, grab a screen capture, put it on your second monitor, begin modeling, use any CAD system you want. What is the correct answer to this challenge? This is a model that was in the finals or the semifinals of the tournament this year. This is like a S-tier level model, so good luck. Try to model this up, see what you can come up with. Lots of feature order creation concerns here. You got to order things in the correct way. You got to make sure that you know how to use the several different types of features, like a sweep or a loft. You got to know how to use a revolve cut, probably, or some other solution for that weird hole. You got a lot of little gotchas in this model, so be on the lookout. Good luck to everyone. And I think you're going to enjoy this one. What is the mass of this part in XXX grams? Tolerant is plus or minus 5 grams. Now, for those of you who are just watching today, who are not participating in Model Monday Live, who are here for the tips and tricks, a demonstration of Onshape, or maybe just here for the camaraderie, want to hang out with your fellow CAD enthusiasts, I do have some questions for you as we roll into 2024. And one of those questions is the mouse cam. Left-hand cam, right-hand cam, keyboard cam, mouse cam. This is something that we pioneered here on TooTallToby in the world of 3D CAD. And basically what it looked like was this. We had one camera looking down on my keyboard, stealing all my passwords. We had one camera on my mouse, the mouse cam, And I'm just curious out there for all those of you who are watching, what do you think about the mouse cam and the keyboard cam? Should we do them again in 2024? Do we like those? Let me make a poll here. Mouse cam, keyboard cam. Should we bring it back? What do you think? Oh, yeah. Nah. Too busy. Too cluttered. On screen. Screen is 2 E's, right? What do we think? I don't know. Mouse cam. I went back through and I watched some of my old videos and I was thinking to myself, like, I kind of like the mouse cam. I don't know. I remember thinking that it looked cool in the old days, but, you know, I wasn't really too sure if I liked it or if I didn't like it. It was too cluttered. I didn't really pay attention to them, but I can see how they would be helpful for some people. That's what Chris says. Krasimir says, yes, keyboard cam will be great. You can see all of the little keystrokes I'm doing. You can see kind of the way I'm moving my hand across the keyboard, how I'm laying things out. So mouse cam, keyboard cam, should we bring it back? We're wondering here in 2024. Always good to hear the feedback. I'll probably create some polls like this on other platforms too, but just testing out some material here with the Model Monday Live. We have all our own keyboard shortcuts, all our own shortcuts. Doesn't matter to me, says 51FPV. Okay, good to know as well. Most of the stuff that I use, I made a video last week where I talked about how most of the stuff I use is not really custom key bindings, but instead is using the out-of-the-box stuff. So I don't know if that really makes a difference, but if you have your own already mapped, then it probably doesn't really matter. So let me know. Let's see here. We got some votes in here so far. Let's take a look here. What do we got? 14% says, oh yeah, bring it back. 86% says no. Too cluttered on the screen. Interesting. How many buttons does your mouse have? Let's see here. I've heard that 4 is the optimal number. Interesting feedback here from Bodie McBoatpants. I find that 4 is the optimal number. That's really insightful, really good information there from Bodie McBoatpants. Thank you for that. All right, guys, next question here for the crowd here. Discord. We're going to be opening up the Discord this month, I think. My question for you is, do you need a tutorial on Discord? Should I make a video? I probably should, right? There's probably a lot of people out there who Discord came about after they were well into the world of engineering. Probably don't really use Discord that much, but we're going to start using it. I think you guys are going to be really happy with the community capabilities that are in Discord. So what do you think, though? Do we need a tutorial? Should we make a tutorial video for Discord? Nico Concarne is here. I'm sure Nico knows how to use Discord. He's probably in there all the time, rocking out on Discord. So I'm just curious if you guys need a tutorial, explain like how to sign up for it, explain how to use the different channels, explain how to set yourself up so that you don't always get snitched on if you're playing Minecraft. You know, you tell your wife that you're going downstairs to work and then Discord snitches on you and tells her that you're actually just down there playing Minecraft. That's no good, you know, so how to join in Discord, where to find the channel. Yeah, so the channel's not live yet, Krasimir. I'm going to roll it out probably this week, next week. So it's not quite live yet. It's been something that we've been trying to get. So Chris Knudsen says, I've tried Discord, but maybe I'm just too old. Can't really figure it out. Maybe a tutorial would be helpful. All right, good. I think, Chris, boom, you answered my question. That's what I needed. Nika says, no, I don't need Discord. Not a musician. That's almost like a Cheech and Chong joke. I like it. Nah, man, we don't need Discord. Okay, tutorial would level the playing field. Okay, Rich, thank you. Appreciate that. That's good to know, yeah. I think, you know, even if you guys just use it for TooTallToby, maybe it'll give you, I don't know, who knows, maybe it'll give some of you another avenue to communicate with some of your family members. A lot of people are on Discord. It's kind of cool. Maybe even expose you to some new communities. There's some pretty nice CAD communities in Discord, and you know, and maybe even some Minecraft communities, right? We'll find out. All right, good to know. Thank you guys very much. Bjorn Vanderbroek is here. Says hello, everybody. What is up, Bjorn? Welcome. Thank you. All right, that's pretty much it for the questions for now. Maybe we'll have some more questions a little bit later. Don't forget, go to TooTallToby.com, sign up for a free account. We're going to have more and more functionality in there. We're going to have points that you can earn by doing practice models. We're going to have training, access to training through the website, or access to scheduling for the training, really, through the website. Training's still going to be live, at least for now, so you'll still be with me, with yours truly, hanging out, doing some training together. So that's going to all be through the website as well. Of course, you can also get your NFT, free NFT just for signing up. We got some other NFTs there in the general store that you get with your TooTallToby cash, which you get automatically just by signing up for a free account. So lots of cool stuff in there. Free giveaways. We did giveaways during the, if you guys didn't see it during the tournament, we did giveaways based on people being logged in. I know Nico posted some stuff on his Facebook, his swag bag. You got the TooTallToby mouse pad, the custom mouse pad just for the tournament, the coffee mug, some other cool stuff in there. So, wow, Aaron C. flexing a little bit here, coming in saying, I got the mass of this one. I got it now. You know, he's been through the ringer on that part, so he's coming through. Let's see if I'm not saying that's the correct answer or not. I'm just saying that's the, you know, that's what he's getting for his answer. You know, I started watching. I tried watching that. There's like a new Squid Game show on Netflix. It's like a real life version of Squid Games, kind of. And man, it's so boring, and they like drag stuff out so much. Not really my cup of tea. But all I could think the whole time was like, why don't they make these guys do CAD against each other? If they're gonna like really make this intense, they should just have these guys try to calculate the mass of something. You know, like maybe model up those bunk beds in the show, and then like who can calculate the mass first. I think that would make for a way more exciting Squid Game. So Netflix, if you're out there watching, reach out to me for the next season. I'll help you out. I'll help you come up with some really cool challenges. We can find out what's going on. We got Ricardo Jean in the chat here, coming in with an answer. Victor K in the chat. Wow, the champ is here, you guys. 2023 world champion of 3D CAD speed modeling is here with us in the chat, hanging out, doing these challenges. This is pretty epic. Toby, I've been doing some more modeling with mesh files lately. Shout out to REVOPOINT. SOLIDWORKS really struggles with them. What's the best way to improve performance when modeling with mesh files? Wow, that's a great question. That might be a good question to ask to Victor K. I know he's got a lot of experience with this. And you know, this is a great example of where we could use the Discord. We could set up a Discord channel. We could have a real deep conversation about this and share some tips and tricks. So, Krasimir says, has to go do an interview for mechanical design engineering position. All right, well, good luck. Good luck. Don't forget, if they ask you to model something, make sure you fully define your sketches. That's probably what they're looking for. Fully define every time. Dom coming in here with an answer. What's up, Dom? Welcome, welcome. All right, guys, let's go on here. Let's talk about some Onshape 3D modeling. Aaron, see, I know I didn't really answer your question there. I don't really have a good answer yet. I'm still finding my way through some of that stuff as well. Oh, Dom revising his answer. You can revise as many times as you want. Nico says, oh crud, I missed the first model. Don't worry, Nico, just roll back. In fact, you know what? I'll help you out here. No problem. We'll go back. We'll take another look. It's this one here. There you go. Grab a screen capture. You can still model up. You still got time. I'm going to do a little Onshape modeling here. You got time. Blast through this one. Take a screen capture. And then you will be able to participate. All right, I hope that was enough time. If not, just roll back the video. All righty, some 3D modeling in Onshape. Let's do this guy here. This is from the tournament, early in the tournament. Lower tier model, not super complicated, but kind of a cool model and kind of a cool chance to use some patterning functionality. Great, thank you, Victor, responding to Aaron. Aaron, take a look at what Victor's got to say in there. I'm sure that he can point you to the right solution there to help with converting your meshes. All right, so this model here, this is called the hose port. I'm going to model this up using the free version of Onshape, onshape.com/free. And as always, whenever I'm creating a model, I always try to look at the model and ask myself, you know, what would be the starting feature? Where would the first sketch be created? I think that this model here, because it's got this kind of stepped area, I probably would do it as a revolve. Of course, you could also do it as two, 2D circles and then extrude those circles. But I just think that because it's got this kind of stepped region right here, and also because it's got this kind of angled face here for that 70 degrees, it just makes sense to kind of start out with a cross-sectional view of this thing, and then to turn that into a revolved shape. And then after I've got that revolved shape, I think what I'll do is I'll take one of these circular shapes here and cut, boss extrude that through the model, and then I'll do a cut extrude through the model, and then all that's left to do is just do a circular pattern. And I think that when it comes to creating that geometry, it probably makes sense to create the geometry here at one of the 90-degree locations, just because it's going to be easier to lock in. And then I should be able to just rip that thing around as a circular pattern, and boom, we are done with that model. Not a very difficult model, but one that came from earlier in the tournament when we were still working with the kind of lower tier models, getting people to, just to kind of work their way through those earlier levels of the tournament. So I'm going to start out by grabbing a screen capture of this print. I'm going to move over to my second screen, and we are going to jump into Onshape. This is the free version of Onshape, onshape.com/free. Really cool that they offer a free version of 3D CAD for anybody who has a computer and a web browser. So I'm going to say create a new document here, and I'm going to call this 23-T-29-hose port. And we are going to jump into this now. We're going to start out by going to our units in Onshape. So up here in the upper left, we're going to go to the document units or workspace units, and we're going to change this to inches, and we're going to change this to pounds because we're looking for this answer in pounds. And then we are going to go to the front plane, begin a sketch. I'm going to orient my view with the N key. The letter N is for normal 2 in Onshape. And then I'm going to create this geometry like so. I don't really know why I made the step like that. That was not really my plan originally. Just kind of, I just kind of did it. But then after I did it, I thought to myself, actually, that kind of makes sense. That might actually help me as I'm creating this geometry. I'm also going to create a line here starting at the origin going up, and I'm going to press Q on my keyboard, which is the shortcut for construction geometry. This might be a cool spot to have the keyboard cam, right? We could be showing off some of these shortcuts that I'm clicking on the keyboard. But you can see here that now that I've got that construction line, I can create my dimensions to that construction line and get what are called doubled dimensions or diameter dimensions. In this case, you can see Onshape actually adds the diameter symbol there. So it just kind of makes it easier for you to match up to what's shown on the print itself. Makes it a little bit easier than having to sit there and calculate the doubled dimension. Now this dimension here, I have to go the other way, so I'm going to go 70/2. That way I don't have to do that math in my head. I can let the software do the math for me. And then for this line here, this is our 1.75, and then our final geometry down here to this lower line is going to be at 3.25. So, it's not like I said, it's not like a super complicated model, but it does show the value of kind of coming up with a plan. I knew exactly what my first sketch was going to be. I kind of planned it out in my head and then put that plan into action. And then, of course, along the way, if you run into any hiccups, you can adjust on the fly. But in this case, it looks like that's pretty much what I was expecting to have created, and that's what I ended up with. So now I'm going to go to this face here, beginning a new sketch, orient my view, and I'm going to create a circle. And it looks like this circle is on what's called a bolt circle or a BC. Sometimes you'll see this in a 2D print. You'll see the phrase BC, and what BC stands for is bolt circle. So if you ever see something like a construction line in a 2D print, and then that construction line says BC on it, like this one says 5.75 BC, that usually means bolt circle. That's usually what that's in reference to. So we've got our radius of 0.5 here. 10 spaces equally spaced. We've got our diameter here of 5.75. I think this looks pretty good. Let's do an extrusion here. We're going to take this extrusion up to a face. So we'll go up to this face here, and that looks good. And now we just need to punch a hole through there. We could do this either by doing a cut extrude, or we could also use what's called a mate connector in Onshape. Mate connectors are often pretty helpful when you're doing a hole. So I'm going to do this as a regular simple hole. I'm going to say that this hole has a diameter of 0.5. I'm going to say that that's going to go through. And then here, I can choose this option for select mate connector, and I can select the mate connector coming off of that circular edge there and punch that hole through. I feel like, wait, did I make that diameter wrong? That looks a little bit, 0.5 for the diameter there. Just feel like these look like they're a little, I guess it looks okay. I'm looking at the 2D print here, looking at my model, and just kind of, I guess it looks right. Overthinking this a little bit. All right, so now I'm going to take these two features here just by picking them in the tree. Pick one, pick two. You don't have to hold shift or control or anything in Onshape. It has what's called persistent selection. So you just pick the things that you want, and then go into circular pattern here. And whoops, it didn't get those because I'm doing a part pattern. I want that to be a feature pattern. So I'm going to pick this feature and this feature, and then for my axis, I'll just pick this face here. And there we go. That looks pretty good. And we're going to say that that is going to be using 10 instances. And let's see here. I'm getting an error. Let's see, reapply features. There we go. Make sure that it took care of that in the correct order, and that looks pretty good. Let's assign a material to this. So the material is ABS, right mouse button, go to assign material. And I'm going to use this from the TooTallToby custom library materials, ABS, and now we're going to measure this part, and we're going to come up with a mass of 1.351, and the correct answer is 1.35. So that's how you would do a part like that. A little bit of a simpler part than what we normally do here on Model Monday Live. But I think it's good to mix it up. You know, not everybody is as experienced. There's a lot of students who are watching the show these days. And so hopefully that gives you some guidance. Again, the big takeaway there is before you get started creating your geometry, just think about how you're going to create this model. There's usually going to be more than one approach. We could have created a circle here and extruded it up to this face and then created a larger circle and extruded that up to this location here. We could have done, you know, there's several different ways we could have done this. We could have included those circles in the sketch as part of that pattern. I think that would have created a kind of a cumbersome or a complicated sketch. I don't think I would have done it that way, but there are a lot of different ways to create a model, and it's good to kind of think about how you're going to create the model before you get started and then go through and create that model. So that is our hose port example. If you like that kind of thing, be sure to hit the like button. Looks like we got 26 people watching. Looks like we got 13 likes. Let's see what we can do to get that ratio to be 1-to-1 instead of 0.5 to 1. So hit that like button if you could, please. Hit the subscribe button, share and reshare. And of course, you could also provide some value for value. Always very much appreciated over at TooTallToby.com/donate. All right, let's get into our answer here. I saw a lot of answers coming in as we were going through that. I saw there was a great discussion going on with Aaron and with Victor. So I hope you guys had a chance to kind of read through that. Lots of good stuff in there. We got Roberts Peterson's in the chat here. What is up, Toby? What is up, Roberts? Apply per instance. Yep, the checkbox apply per instance, or it looks like it's a little bit different check mark. I don't know if that's because I'm in circular pattern or because they ran an update and kind of changed it. But it was that other check mark that got me through. Yep. Okay, I'm just kind of rolling back in the chat here, seeing who is answering this thing, seeing what they're coming up with for an answer. I think it was Aaron C who came up with the first answer there. Yep, Aaron C, and then we got Tom. Okay, all right, good. I'm all nice and in line here. So let's see here. So for this model, the hex arm, kind of a tricky one, kind of a tricky model here if you don't know how to loft or sweep with a guide curve. But that's the trick. You have to learn how to loft or sweep with a guide curve. I'm going to post this one as a practice model, and so that'll give everybody out there in the world a chance to give this thing a try. But for today's challenge, it was Aaron C who came in with the first answer, 625.9, so 626. We'll round that up to 626. Ricardo Jean, 627. Victor K, 627. Nice. Let's see here. Dom coming in, 744. Very nice. And what else do we got in here? We got Amir Shea coming in, 624. Very, very nice. So the correct answer within the tolerance of plus or minus 5 grams is 626 plus or minus 5 grams. And that 5 grams is to account for if you did it as a sweep, if you did it as a loft, if you use one guide curve, if you use two guide curves. Lots of different options here that can maybe create some variance in that answer. And the correct answer is 626 plus or minus 5 grams. So that answer is going to go to Aaron C, 626. Perfect. 625.9. Aaron C gets the point. Guys, let's give Aaron C a GG in the chat. Well done, Aaron C. Well done. Chris Knudsen says, with respect to the various fees charged by YouTube and PayPal, does it work out more in your favor whether we donate YouTube Super Chat or via your website? It works out much better via the website. Yes, thank you for that question, Chris. It is a much better deal for the TooTallToby crew and for you if you do it through TooTallToby.com/donate. That system is it's much better, put it that way. So thank you very much for that question. Great question. And GG in the chat. GG to Aaron C. Our third 3rd/4th place finisher, 3rd and 4th tie. When you do a heads-up tournament, 3rd and 4th always tie. So congratulations to Aaron C. We're just going to say our 3rd place finisher in the World Championship of 3D CAD speed modeling. I guess you could say Aaron C. is the 3rd fastest speed modeler in the world. I mean, if you want to be fair. So congratulations to Aaron C. GG. And I'm glad to hear that you are rocking that new REVOPOINT 3D scanner. That is awesome. All right, guys, let's move on. Let's talk a little bit more about the world of 3D CAD speed modeling and give you your second challenge. I've been saying 3rd place when I talk about 2. Yeah, exactly. Yeah, exactly. That's exactly what I would say too. You guys were on that 3rd place podium, and I think that that is perfect. And this is just the beginning. You just say, hey, listen, that was just my warm up for 2024. I wanted to give Victor K a chance to win the championship before I come in and just win it 6 years in a row. That's how I would talk about it if I was you talking to anyone about this tournament. Just so I can retire, exactly. Just so Victor K can retire. All right, guys, let's go into the second challenge here. I'm going to flip over to full screen. I'm going to show you the 2D print. You're going to turn it into a 3D model. This one is not easy. Here we go. In 3, 2, 1, go. What is the mass of this part? This is kind of a fun one. I don't think we did this one, right? We did this. We showed it. We showed, of course, there's a highlight reel of it, but I don't think we've challenged the chat to do this one. So what is the mass of this part? This is straight from the tournament, so don't cheat. Don't go back and look at the tournament answer. Just try and do it yourself. It's all for fun here anyway. Got to have an Ivan win sometime. Yeah, another Ivan win. He won the inaugural tournament, so I'm sure that if he wins, he'll be the first person to win twice. So we'll see who the first person is to win twice. What is the mass of this part in XXXX grams? The tolerance is plus or minus 2 grams. This is called Space Plate 23T62 Space Plate. This one was made famous by Ivan, the very same Ivan we were just talking about. He got himself into a jam, and he got himself into a jam, and he ended up using a really cool move bodies command to fix the jam. It was epic. It was a really, really cool solution. I loved watching it. It really showed his experience in SolidWorks, working with customers, having the customers change things, having the models kind of blow up, and he was able to resolve that issue. Very, very cool highlight reel if you get a chance to watch it. But don't watch it right now. No spoilers. Just try to model this thing up. I'm going to modify this a little bit, and then I'll post a practice model as well. So I always try to modify them a little bit from the tournament version to the practice models version. So, we're going to see a slightly different variation of this thing. All righty. Sweet. Well, I hope that's enough time for you. Grab a screen capture. MMGS 1060 alloy, 2,700 kilograms per cubic meter. Space plate. The space plate. I remember I was doing commentary with Michael the Flesh when this one came up. And it was fun talking to him about this part, the space plate. All right, guys, let's continue on here in our beautiful Monday, December 11th live stream. We had crazy weather here. East Coast, United States. I was very worried the property was going to flood, and it didn't. We've been building some infrastructure to stop the flooding. If you've been a longtime watcher of the channel, you'll know that several years ago we flooded, almost lost everything, but managed to recover and got ourselves back up and running. And it was a little bit crazy. And so we put in some steps. We built a wall. We put in some other measures to make sure that we didn't get flooded again. And past couple days, we've been getting some pretty serious rain, but it did not flood. We're dry as a bone in here. So it's a beautiful thing. Toby is a happy camper. All right, let's keep going here. What's going on in the world of TTT news? We do have 4 training classes ready to rock, ready to roll out, ready for all of you to consume. CSWP Prep, a tips and tricks training, just advanced tips and tricks, kind of like a combination of all the power moves and some bonus moves you haven't seen before. Intermediate/advanced part modeling, intermediate/advanced assembly techniques, So lots of cool stuff you can do with lofts and sweeps and multi-bodies in the part modeling class. Lots of cool like filleting, advanced filleting techniques, curves, learning how to do different kinds of projected curves, split lines, stuff like that. And then the advanced assembly techniques, all the different mate types, using large assembly troubleshooting to try to figure out why your large assemblies are so slow, using layout-driven assemblies. So lots of good stuff in those customs, all custom training manuals that I've written from my experience, and I think good stuff that'll help any team. If you're interested in that training, just kind of be on the lookout. We're going to be adding a training section to the website. You're going to be able to go to the website. You're going to be able to let us know if you're interested. So just be on the lookout. And if you haven't signed up for a free account yet, sign up for a free account at TooTallToby.com. That way you'll get notification when the next training classes go live or are available for sign up. We're going to do kind of like an interest poll for those training classes to figure out when the first ones should be scheduled. But they will be in with me. I don't want to say in person. I'm probably not going to come to your facility because it's probably going to be multiple people. But it will be an actual live meeting. It's not going to be like watch these recordings of me. We're gonna do it live. We're gonna do real interaction, real question and answers all throughout those training classes. So very excited to be rolling that out. 2024 is going to be a big year. Got lots of stuff going on. And guys, we are right on the cusp of hitting 10,000 YouTube subs. So very excited about that. 9772 when I looked this morning. So just a few more and we are going to be there with our 10,000 YouTube subscriptions. It's been a real fun build to this, and excited to see what happens when we get there. What do you guys think we should do? Let me know in the chat. What do you think we should do when we hit 10,000 subs? Should we party? Should we have a massive party, a blowout? Should we do it? Maybe it'll happen. Maybe it'll coincide with New Year's. That'd be kind of cool if it coincided perfectly with New Year's. Maybe we'll just do some Christmas carols. We'll sing some Christmas carols for 10,000 subs. Let me know if you have any good ideas of what we should do in the chat. And we will, I'm sure, have like a special live stream when we get close. If if I'm awake and it gets to like 99.90, something like that, I'll go live and we'll try to push it across that finish line. All right. Don't forget there's a tips and tricks section at TooTallToby, TooTallToby.com/tips. Good way to search for our tips and tricks. The Spring Open leaderboard, it is open right now, the TooTallToby Spring Open. So if you do go to TooTallToby.com and you look up at the top here where it says tournaments, there's the 2024 Spring Open Tournament leaderboard. And basically this is where you can qualify for the Spring Open. What we're doing is we are obfuscating the results of everyone aside from the top 4 runners. So if you want to see the way Dom did this using SolidWorks, he did the whole thing in 3 minutes and 22 seconds, 3 models in about a minute per model. If you want to see it the way Mr. Alex did it, if you want to see the way Airwick did it using Onshape, if you want to see the way Ex Machina did it using Alibre design, huge supporter of the show, this is your chance to kind of see what those top 4 people did, and maybe that can help you come up with a strategy. Maybe you can even bump one of them out of the top 4. We're going to take the top 16. We're going to pit them against one another. We're going to have ourselves a Spring Open tournament. So join us and let us know what you think about that. The Spring Open leaderboard is open. All right, let's get into some Onshape 3D modeling, some sheet metal. Here we go. This is Victor K's favorite part. 23T81 flared bracket. Kind of a tricky part here. You can see here that we tried our best in the 2D print to let people know kind of what to expect and how to avoid running outside of spec. Probably the biggest part of that is this region right here, this bend region flared wall. So having this section here straight and then having this flare out is key. If you start flaring out too early, you're going to end up too wide on your dimension down here at the bottom. So definitely a fun part, a challenging part. And when this one came up in the tournament, it was Victor K versus Mons. There were some questions from the co-commentary of whether or not Onshape could even handle a part like this in sheet metal. And the answer is absolutely Onshape can handle it in sheet metal. And we're going to see a demonstration of that right now. Now, Airwick is an absolute Onshape genius. and I'm sure that he will have some feedback for me. One thing that Airwork does that I really enjoy is he takes my models after I kind of struggle my way through them, and then he just redoes them on his YouTube channel and shows how a professional would model this using Onshape. And so it's really cool, and that you can really learn a lot. If you're trying to learn anything about Onshape, be sure to check out on my videos. If Airwork leaves a YouTube comment, look at his video. And you'll see kind of the correct way to do it, the optimal way to do it. But I'm going to create this model here. You know, again, just like I mentioned in the previous example, I'm going to look at the model. I'm going to come up with a game plan. One of my game plans is going to be to recognize that there's symmetry in this direction, and there's symmetry in this direction, and there's symmetry down here in this lower view in that same direction. So that means that I could probably not model all of this and just focus on this one corner here. So that's how I'm going to do it, and then I'm going to mirror and mirror at the end, and that should make things at least a little bit easier for me to create this model. I also mentioned that there's this kind of flare out section here. It flares out at 26 degrees. And that flare out section starts here. So I think what I'm going to do is I'm going to start with the first extrusion as a sheet metal extrusion, but instead of just going to 80, I'm going to go beyond that. I'm going to go to like 120. This looks like it should be about 110 here in this view. And then after I've got that out to 120, I'm going to create a cut extrude. So I'll create a cut extrude that looks like this. And that way I can kind of cut away that flared area. Instead of maybe like modeling it at 80 and trying to add that, I'm going to just model it wide and then cut that extra area away and see if that gets me pretty close. I'm also going to be a little concerned about what's going on down here in this section. If I were to create that cutaway, I've got this kind of extra little corner sticking out here. So I think what I'm going to do is I'm going to first get the flange that's, you know, the kind of the top section of the model, and then this flange that's sticking down here. But I'm not going to create this extra geometry that's sticking off the side here. So my first sketch is going to look just like this, these two lines, bring that out, cut off that flared region, and then I'll go back in and add another flange that comes in this way. So that should help me to avoid, you know, running into a challenge with regards to inadvertently lopping off this little sharp corner here. These are just kind of things that you learn over time when you do a lot of 3D CAD. You kind of learn how to look at a model, whether it's a physical part or whether it's a 2D print, and kind of like unbuild it in your head and imagine what the feature tree is going to look like. And then you go through and actually try to create the model. So let's get into it here in Onshape. I'm going to close this model. If you've got the free version of Onshape or the paid version of Onshape, you can do a search in the public space and you'll be able to find this document, 23-T-81-flared bracket, and then you can take a look and you could see if you're coming up with the same results that I'm coming up with, or if you get stuck, you can kind of look through the feature tree that I've created here in Onshape. So I'm going to start out by creating just these two lines, just like I talked about in the game plan. I'm going to make sure that this is horizontal, which it is. I can see from that relationship that shows up there. I'm going to create a dimension here that goes to the sharp and goes here to the center of the model, and that is going to be 170/2, 170 to the sharps. I'm going to create a dimension that goes from the floor up to the very top of the model. That's going to be at 65. And I'm going to create an angle dimension here, and that angle dimension is going to be 60 degrees. Gives me a nice fully defined sketch. Going to hit the green check mark, and I'm going to take that fully defined sketch and turn it into a sheet metal model using the extrude option. So I'm going to take this geometry here, extrude it to a thickness of 4 millimeters with a radius of 6 millimeters. So 4 by 6, and then I'm going to bring this out to 120/2. That should give me enough room to kind of cut that thing down. The last thing I want to look at is the direction of the sheet metal. The dimension that I put in here for 65 is from the floor to the peak of the sheet metal, or to the top of that top surface. So this needs to go the other direction. So whenever you're doing sheet metal, you have to look out for the direction of your sheet metal, and that option is right here in Onshape. So now I've created that first shape. Now I'm going to pick this face here, begin a sketch, orient my view, and I'm going to create that second shape, which is the kind of flaring off of that geometry. So just create this second shape here to look something like this, kind of flare off that geometry with that second shape there. And then I'm going to be able to put in my dimensions. So this is going to be 80/2, or I can actually just do that in my head. I don't mean to flex or anything, but I can figure that out in my head. I'm going to say this is 26/2, so that's going to be 13. And then I'm going to jump into an extrude command here and remove that material. And you can see in Onshape, they give you a nice preview of what that remove is going to look like. So I'm going to say that this is going to go through all, kind of remove that whole section there. And there we go. That gives us that nice 40 millimeter wide up top there, and then that flare out at 26 degrees. So now I'm going to pick this edge, I'm going to pick this edge here. One thing that I'm going to do just to kind of prep this feature is I'm going to get my my top plane aligned here, because the distance from the top of the model down to the lower flange of the model should be that 65. So when I make this lower flange, I want it to be flush with this top plane. And so by extending that top plane, it just kind of gives me a visual cue, and that way when I go into the flange command in Onshape here, I can start making some adjustments to that flange command. So I could say this is going to be 90 plus 30 to account for that kind of, I guess it would be supplementary angle or complementary angle. And then I'm going to get normal 2 here, 120. And then I'm going to get normal 2 here, and I'm going to change my option here for the flange position. And by changing this option, I can maybe figure out which one is going to give me that flange flush to that plane. So just having that plane there, I can just kind of iteratively go through and look at the different flange options until I get the right one, just by making that plane a little bit wider. So that's something that we sometimes do in 3D CAD. And then for the stop point of this flange, I'm going to say the stop point is going to be offset from the middle plane here, and that offset is going to be 75, so 150/2. So that gives me that flange sticking out of the bottom. I think that looks pretty good. I could do a quick sanity check here and make sure that this distance, so if I pick here on this edge and then I look down here in the graphics area, that distance is 56. If we remember from the print, there is a reference dimension here that says that this should be about 112. So 56 times 2 is 112. So I'm pretty much in line with what that reference dimension is. So just kind of like a quick sanity check there as I'm going through and creating this model. Now, this next flange here is a little bit more tricky. I pick this edge here. I jump into the flange command. I bring a flange off of this thing. I'm going to say this one's going to bend to the hold line. So that means the bend is going to start right there where that original line is. And then the flange length is going to be a partial flange. So this is going to go to a distance of 110/2. So 55 there. Or actually, that should be from the other end. Let's see here. That's not the correct distance there for my flange offset there. So maybe what I'll do is I'll flip where the flange is starting from, and then I could maybe make that offset up to entity with offset, and I could go to here. Actually, no, we do want that off from there. Okay, there we go, and then make that 55. There we go. That's what we wanted. So sometimes you just got to kind of adjust those different parameters until you get what you want. And then my bend angle for this one is going to be at 75 for the bend angle. And then this is where it gets tricky. The length of this segment right here, the straight segment, is supposed to be 20 millimeters. So here on this print, we can see that it's supposed to be 20 millimeters, the length of that kind of straight section to the bend, this little straight line here. And so the way that I usually do something like this, if I can't figure out a good, elegant solution to let the software do it for me, what I'll usually do is just kind of fire it in there with the default and then click on that edge. So I just clicked on this edge here, and then I look at some kind of a measure command. So in Onshape or in SolidWorks or whatever you're using, it's 17.33. So if we take 20 minus 17.33, then that leaves us with 2.67. So what we could do is we could edit that flange there, and we could just add the 2.67 to this 25 dimension here. So we could do, 27.67. I know that's not like a crazy dynamic solution using the software and equations and stuff like that, but it gives you the result you need, and it lets you get the model over to the customer. And sometimes that's really the name of the game. It's just getting that model over to the customer. So just kind of something to think about. It doesn't always have to be like crazy dynamic equations where you're leveraging the parametric capabilities of the software. Sometimes you can just kind of brute force your way through. So this is going to have a radius of 14 here. We're going to add that fillet radius there. There we go. Now we get to the next tricky area of this model, which is that this kind of slotted shape here and this slotted shape here don't perfectly line up. So I can't just fire a through cut. So what you have to do is kind of like a stepped approach to get that to go through both segments. So what I'll do is I'll start out here on the top of the model, and I'll create a slotted shape here. I'll just come all the way around with this slotted shape here. And then what we'll do is we'll take this and drop it so it's nice and centered, and we'll give that the designated radius here of 12 millimeters, and then the location of that is 140/2, so 70. And then what we can do is we can take that and we can cut extrude it down into the model. We could probably even cut extrude it all the way down to this point. So we could do extrude here, and we're going to remove that down. And then we could either type in a distance like 40 millimeters, or we could even go all the way down to that point. Either way, the point is we're not going to go through the whole model, and then we're going to create a second cut here. So we could create a cut here on this very bottom surface, this surface here. And then that second cut is going to use the same kind of geometry here. So we're going to do line, arc, line, coming back and touching that endpoint to activate that line arc line command, close that off, and then again we'll bring this out to here. We could say that this point and this line here are coincident. We could say that this point and this line here are coincident, and then we can put in that final dimension. So that final dimension is going to be from this point and this point here, and that distance is going to be 190/2. And then what we could do is we can take that and we can do a remove, and we can really just fire that one through all. So that's kind of the trick to that feature. You have to do it as a two-step process. I don't think there's a way you can just get that whole thing at once. I know I saw some of the runners trying to do it by like flattening that sheet metal and then doing it as a slot, but I don't think there's a good clean way to do that. And a question came in here from Amir. Can Onshape cut up to surface? Yep, absolutely. You can do up to surface. It's in that end condition. I'll show you here with this feature. So now this final feature is the rectangular cut up top to create a relief for the that final flange that's kind of sticking up. So this is a 30 by 30 rectangle, but we're only doing half of it in this direction. So it's going to be 15 in that direction. And then this is also offset by 30. So again, it's only half. So we're offsetting that by 15. And then we're going to do an extrude cut. And then you can see here that in the end conditions in Onshape, we could do that as up to face and then pick this surface here. And that would be like your up to surface end condition, Amir. So yep, you can do up to surface for sure. And then this final feature here, I always manage to struggle with this feature regardless of what CAD system I'm using. Creating this final like tabbed area that's sticking up out of the top here, just partially because of the way it's dimensioned, but it's supposed to stick up 20 millimeters total off of the edge here. So we'll take this edge here, we'll do a flange. We're going to reverse the direction of that flange. I think it's going to actually be 24 because it's using the material thickness as well, because I picked that lower edge. So it's going to be 24. We're going to do that using the hold line, so it bends from the original location. And then this is going to be a partial flange, and that partial flange distance is going to be, I think if we do 5, then it gives us that gap of 5. Yeah, that's what we wanted there. So there we go. I didn't actually struggle with it. It wasn't that bad. And then we can pick this face here, and this is going to have a hole. That's going to be 9 millimeters, and that is going to be at a distance from the floor. Here you can see I can pick that center point, and I can just pick the top plane from the tree, and that way I can get that dimension without having to go and find the top plane. That's going to be 77, and then that's going to be remove, and we'll make that through all. And then we can finish up here with a fillet of 7 millimeters on that top edge there. There we go. And now we are ready to take this thing and mirror it. So this is going to be mirror. We're going to mirror the entire part about this face here. And this is going to be merged together. So we do an add, and then we're going to do another mirror here, and we're going to mirror the entire part about this face here. And we want to do add so that those are merged together. And if we look over here in our sheet metal table view, we can see there's what the flat pattern looks like. So I think that flat pattern looks pretty good. That's pretty much what I was expecting to see. And then what we could do is we can assign our material. So assign material, and the material here is going to be from the TooTallToby library and 1060. Okay. Didn't think it was that. All right, and then the answer we're coming up with here is 367 or 368 grams. And that is correct. I had to go and look at my answer sheet. So 368 grams is correct. And that is a sheet metal kind of tutorial, walkthrough, speed run, whatever you want to call it, how to create that model in Onshape using sheet metal. Yes, it can be done. That's the technique that I would use. If you have any thoughts on how I can maybe do that better, let me know down in the comments. Let me know in the chat. And I hope you guys enjoyed that little Onshape tutorial of how to build this 23T81 flared bracket. Little sheet metal action there for everybody. Alrighty, and we are down to the last 5 minutes of the live stream. If you guys enjoyed this live stream today, don't forget to like and subscribe and share and reshare. Take a screen capture of what we're doing here. Share it out to the world. Let them know what we're doing. It's pretty fun here on our Model Monday Live. Just reading the comment from Aaron. Says, Toby's doing a tour de pain for us today, Victor. Yeah, these are models that both Victor and Aaron really enjoyed. So I'm glad we got to do them. Here in Model Monday Live. That's what we're here for. Don't forget that the value for value system is up. TooTallToby.com/donate. A great way to keep the channel alive. Let us know that you like what we're doing here. You can use super chat, you can use super thanks, or of course, you can use the website TooTallToby.com/donate. And let's now find out what the answer is and who is going to earn the point for the space plate. Here we go. Let's see here. Our first answer came in from Victor K, 1589 grams. Our second answer came in from Aaron C, 1647.53 or 1648. Victor K revising his answer, 1648. Wow. Ricardo Jean coming in here, 1659 grams. I like it. Ricardo Jean revising to 1654 grams. Very nice. Let's see what else we got here. Dom Linder coming in, 1648 grams. Ricardo Jean, 1648 grams is correct. Aaron wins. Ha ha ha. Very nice. Amir Shea coming in 1648. Very nicely done. Very, very speedy. And that's it for our answers. What is the correct answer? The correct answer is 1648 grams. And guys, you know what this means? We got a clean sweep today. Aaron C taking down the first point earlier, coming in with the correct answer, which was 626 grams. Very nicely done to Aaron C. And Aaron C taking it down the second time. Wow. And Ricardo Jean coming in with some super chat, €5. Thank you so much, Ricardo Jean. Very much appreciated. Wow, that's awesome. Aaron G for the double point, gets both points, gets a bonus point for having the clean sweep. GG to Aaron C. Congratulations, Aaron. Well done. Getting ready, getting warmed up for the next tournament. I like it. And Ricardo Jean, again, thank you so much. Amazing content. I appreciate that. Amazing chat. You guys really are the secret ingredient to this whole thing. So thank you all so much. Thank you all so much for joining us today on this Model Monday Live. Congratulations to our winners, but really congratulations to everybody in the chat who did it. If you finished either of these models, you are amazing. You are on the right track. If you didn't get to finish them, keep practicing. The speed will come over time. And don't forget to check out our partners, SolidBox. They are amazing. If you ever have any kind of IT computer question or a need for new hardware, check them out, mysolidbox.com. If you want to learn more about Onshape, check out the SolidWorks Expert Learns Onshape YouTube playlist on the Onshape YouTube channel. If you want to learn more about Alibre, check out Alibre.com. We're going to hear a lot more about Alibre coming into the next season of Model Monday Live. We're going to talk a lot about Alibre. Everybody in the tournament got a seat of Alibre. So huge shout out to the crew at Alibre for hooking up all of the runners. And again, thank you so much to you, the most amazing chat ever. Check out the Spring Open 2024, the next tournament. The registration is live, TooTallToby.com/spring. And sign up for a free account at TooTallToby.com. And of course, thank you all so much. This is the end. Next week is Monday, December 18th. We're going to go live again next week, 1 p.m., Model Monday Live. In the meantime, please watch the practice models videos, like them, add comments, watch the shorts, watch the pro moves videos, and be sure to like and share any of the social media text and images that we post throughout the week. It goes a very long way. If I share something and you share it on your network and somebody on your network shares it on their network, that's what we like to call network effect. That's how you get out there. That's how you touch all the different nodes on the network. And that is how you grow a channel. So please help out by sharing the content. It really goes a long way. Thank you all so much for this amazing Model Monday Live. I will see everybody next week. GG, Aaron. Good job. Way to dominate the competition today. See you guys.